Restarting the stream here. I think I had a mistake, a little issue going on with my Vive base station. I think it was vibrating and the tracking was making a mistake. So let's start from the top. Today's lesson is here on using the particle system in VR in Simmetri to make a particle blaster, which we put on our right hand or wherever you want it, on either hand, and then use the index trigger to fire it. And what we've got is it moves out pretty quick, kind of blasts out really fast, and it's got a light on it, and it's got a particle, a set of particles that dust out from it and kind of expand like they're, fiery hot gas. And I've, just built this. This is in an open space. It's you can right click underneath the universe in the library, and we'll be showing you how to do that. You can create a new open space. We used this open space. It's just got a black background, and it does have physics in it, but gravity is set to 0. It's kind of like a outer space kind of world, and yeah, so I'm able to kind of fly around. I built this little structure really quickly to kind of just have some stuff for it to fly through and illuminate. You'll see that all of the things that I've emitted leave kind of a light in space, which is pretty cool actually, to kind of shoot a flaming fire. It's kind of like shooting a meteor that never goes out. And it's pretty cool too. I can like fire into this structure and illuminate it, and kind of if I get the full distance away from this object. I'm now adding a ton of light into that structure, but it's pretty cool. It kind of lights up this sculpture. Anyway, this was set up really simply. We're going to set it up very quickly. It's literally one line of code. Most of the focus today will be looking at both the particle system and then the way that we get this particle to make this trajectory using what's called a unit and a timeline. If you've been following us for the 30 days of Simmetri, you'll know that the unit plus timeline is a way to package up kind of some animations. Animations just meaning, setting any property value or keyframe properties across, using one or multiple timelines. And these units are the thing that are emitting out of my hand. I emit these units, and the unit has a little particle emitter which has a timeline that is it has its position marked out in the forward direction through time, and by emitting that particle by emitting the unit with that timeline, the particle emitter, every time it gets emit, it follows that timeline path from time 0 to however quickly it gets to its finished its final position, its final destination. So yeah, it's really a few components here: a particle emitter, a node inside of a unit and timeline, and a node emitter which emits that unit, and then connected that to your hand, and then just one line of code that'll make it shoot. So let me just we'll dissect this show and then drop right in. I'm actually just gonna select all these boxes that are in the space, and I'm gonna hit Control E, which groups them. Take a second. Yeah, it's kind of like merging the layers in Photoshop. Control E will group them up. And now you can kind of see that our show is not that complex. We literally have a VR rig, and we've got a node emitter sitting on our right hand. So under the right hand, close down left hand, under the right hand is the node emitter. And the node emitter has a sample, which is this unit that we're going to build, which is a unit in the library. We may or may not go. We're going to actually just leave our unit in the space, and we'll make that our sample. And then that unit is a unit plus timeline. And so when I press the index trigger of the right hand, when I press this index trigger right here on press, I literally do one line of code, which is I get my parent. I'm trying to get a sibling, so get my parent and then find node by name. It's like go talk to mom and dad and go ask for my brother. get my parent node, which returns, see this, the code running here, goes and gets its parent, and then it goes and grabs its node, the child of that that node, parent node called right hand, returning node emitter, and then we have a simple. All we do is just emit one of those, emit that node. So when we press it down, we emit the node. Pretty straightforward. So let's basically build one from scratch. I'm going to create a new open space in this project, and we're going to start off by looking at the particle system, and then we'll build our blaster up from there. So a particle emitter is the primary tool we're going to be using. I'll put a few things in the space just so you kind of have a little bit of depth and reference here. We're going to put a particle emitter in the space, and so what you'll do is you come under emitters, and the node emitter we've played with, that emits, oh boy, I'm going to deactivate the VR rig, and I'm going to deactivate the display on that, so we won't jump over there. So a node emitter actually emits like it emits a sphere in space, and that sphere has, you know, physics on it and whatnot. So now these things will kind of collide, right? So that's a node emitter. A node emitter emits and basically one of these items. You can choose that node emitter, and we're going to be using this a little later. I can pick what it's emitting, and I can literally say emit things like this, and it starts emitting things like that. So that's a node emitter. It emits this whole thing. It's a three-dimensional object, or it's a kind of conceptual object like a particle emitter or a light. You know, that doesn't have volume per se, but has that is a larger object, a larger conceptual object. A particle emitter is a special type of emitter that we're going to be using. I'm going to go ahead and stop again. I'm going to delete our node emitter for the time being. A particle emitter, under emitters, a particle emitter will be emitting particles. And it's emitting more quickly. And a particle is just, you know, some of you will absolutely know what this is, and this will be total review for people who are new to this. Particle emitter is kind of like a little tiny two-dimensional, you know, image, basically like a JPEG that's, you know, it literally can be reading from a JPEG. It's got a little texture and a material on it, which is always facing the camera. And since we don't have to worry about its like depth information or the angle that light is hitting it and stuff like that, it's much easier to render. So we can put lots of particles in the space before the computer struggles to deal with it. You know, we can maybe put several hundreds to thousands of these objects, these nodes, these items here, these cube entities, but particles we can put, we can get upwards of, you know, 1,000 before we're a couple thousand, upwards of potentially even 10,000 before we're struggling, 10 and 20,000, and then it all kind of really matters. Really just is a question of how strong your GPU is. And if you want to test it, this is exactly what you'll do. So let's take a look at this particle emitter. Right now we're emitting, and you can see it kind of, it's emitting a bunch. The node emitter was like emits default 1 per second. This particle emitter is emitting 10 times that amount. I think it's 10 times. And the way you find out is under the particle's properties. You'll see it's pulsing on a constant pulse, and if we click that constant pulse, it's emitting 5 per second. So you can increase this to more, and you'll see more coming out. What if we increase it to 100? You start to see this thing being less of like a few wisps of snow, and now it starts to look a bit more like kind of gas, right? So let's do a few things. We're going to work on this particle emitter, and here's a little tool tip for you. This little plus button will take whatever you've got selected. The camera is always the camera that you're looking through and moving around in the space in the viewport that you're in, whichever the camera is here. That camera is always going to be selected here, right? But then whatever you've selected for viewing its properties, it's going to be this second tab. But if you want that tab to always stay here on this panel, you can hit this little plus button. And now particle emitter is always here on this tab. Furthermore, if I open up this constant pulse and it opens up a new page here, I can hit this plus button and it'll pin. So that's pinning these tabs down, which means I can now move between the particle emitter and the constant pulse. I can also select this box and it's going to be under selected. So if I select a new box entity, here I am under this selected object. A new box entity, I'm selected there. And I can select the camera, so on and so forth. But now I can just kind of come up here and I can work on my particle emitter and constant pulse. And I highly recommend this because what you'll probably do is be tinkering with the values on the particle emitter and its pulse for quite a while, and you'll be moving back and forth. You'll say, okay, what if I get them moving at a higher frequency, a higher rate, and we're emitting a lot more per second? And then you'll come back to the particle emitter and you'll say, what if I change some of these other properties? Anyway, so now that we've got our setup, let's dive in. So what are some of the properties of the particle emitter that are going to help us? We'll go over them overview, and then we're going to try to get to ourselves, try to get to something that looks like, like a flame that moves out. So let's take a look at this particle emitter. If I move it, you can see that it kind of has this nice lag behind it, and they're always these particles are always kind of going in the up direction. And this will kind of slightly depend on whether or not what gravity you have in the space. And in an open space, you have no negative y, so your gravity is just neutral, which means that these particles are coming out of they're spraying out of this thing with physics with some initial velocity. Let's imagine if we just turn this down to 0. Now they just sort of puff out, but they're puffing out kind of in a random order. And what we're seeing is this multiplier on wind, which is causing them to scatter out in that direction, and that's the randomness magnitude, which is defaulted to 10. So if you want to bring that down to, say, 0, we'll see what the change is. You have to hit the number and then click off of it. So now there's absolutely no randomness magnitude in no wind, and there's also no initial velocity. There is a mass to these items, which we'll talk about in a second, but this all of a sudden creates this, with no velocity or anything. They're not really pushing their way out of this emitter. They're kind of just like staying in the location where they were emitted and just kind of growing. So let's put a little bit of initial velocity on them, and you'll start to see this little jet. And if I were to I'll take a look at the particle emitter. Okay, so you can see that they go up with a little bit of velocity. Nothing's really stopping them here in space. So let's actually attempt to stop them with a little bit of physics. And if I start to bring gravity down, there goes our boxes, but so do also these particles. They will only go so much. And I suppose if I rotate, they may start to arc a little bit. Yeah, with a light amount of gravity, they will arc a little bit. If we crank up gravity, they will, crank it down, rather. You'll see them sort of arcing. And that's kind of interesting looking. Anyway, so the overall effect of physics on these particles, very cool stuff to play with if you want to, tinker with, how gravity or the lack thereof, or sideways gravities, may affect your particle. It'll affect everything else though in the space as well. So you may want to work with actually the wind value, which is on your under your physics. That might be a better place if you just want to control. See if I stop it, and I want those objects to stay put, the boxes, but I want my let's just double check where our physics is zeroed out. So everything we do now is going to be controlled by our physics forces. Here we've got a little bit of X. If I double click there on the scrolly bar, we will now straighten out, and you can see it kind of straightening out in the air. What if I click? So I could potentially do things where I change the wind on these things, and right now I'm controlling it with the scrolls in the editor, and I could also go and grab these from script. I can also for example, come over here and say put. If I click here, I can put a number signal controller on one of these, and I could put, which is a signal that's going to control this number, and I could put a new random signal on that, and now you start to see this kind of wavering flicker in a 1 degree of X here in the I guess that would be on the wind. It's a just a directional vector, so it's a little bit of like X back and forth, and it kind of looks like that. I don't know, like a cartoon, like the smell coming off the cooling, like cartoon pie. It draws a cartoon character in. Anyway, so a little bit of randomness gets us this effect, and so you can already see that if we take some randomness added to our wind and we do something with, if we reduce our initial velocity, maybe we're just going to get a little bit more. It's going to be a smaller. The particle will kind of wisp a little bit, like less up into the air. There's just a little less velocity. And then randomness magnitude. This puts randomness across all of these values. We've got kind of an extra amount of randomness in the X. But that's across each particle, and this will go. Sorry, randomness will happen across each particle, and I think the wind is kind of happening in mass, like, so it'll get much more applied. So you'll still have kind of this wisping back and forth due to the random signal we put on this number signal controller on our X value. And then there's this generalized randomness magnitude, which is like spreading them out over time. If you keep cranking up randomness magnitude, you're going to get much more of a like puffed out kind of thing. An explosion, of course, is kind of way more sort of scattered, situation in a, smoke sort of dense, kind of almost like foggy, cold smoke kind of thing might be a little bit more. Might have a little less randomness. So that's the physics stuff. I kind of like to show physics in this overall continuous amount, the pulse and how many are getting emitted first. So the constant pulse is saying that we're emitting 387 per second. Okay, so 387 per second. Let's make that a round number. Let's make it like a cool, like 400. So 400 are getting emitted per second, and then eventually they're dying off, right? You're seeing them they come to the end of their life. Well, what's telling them to come to the end of their life? Well, it's back here on the particle emitter, which is the max simultaneous. Just also happens to be my handle on Discord and on the Steam server. Nice to meet you. I am max simultaneous, and this is my property in Simmetri. Max simultaneous is the total amount of particles that we're allowing in the space. This is the way that you can kind of keep tabs on having too many particles, and this is also a place where, if your hardware can handle it, you can crank up the total number And it'll also it'll kind of equate to the lifetime, whichever one of these comes first. So lifetime is quite literally how long those particles can live, and if they live, if they aren't kicked out of the world, essentially orphaned out of the world, as it would be called, kind of deleted out of the world because they've exceeded the max simultaneous value, they will last for 5 seconds. So let's do a little math. So our constant pulse is emitting 400 per second. We can even do it like 500 per second, which means that we will hit 5,000 in 10 seconds. And if the lifetime is 5 seconds, it's the lifetime which is going to be making the limitation on how long these things live. But if we made this lifetime much longer, like 20 seconds, anything over 10 in this case, the max simultaneous value is the one that's going to be limiting them. Anyway, something to keep in mind, these are two of your controls, the lifetime, and we can see we're now starting to get a lot more particles in the space, and it's filling up a bit more. My fan might kick on in a little bit, but yeah. So anyway, so we've got this. What else do we got going on? So total to emit. This is literally kind of like it'll emit a certain amount, and then it's done emitting entirely. And what that means is that it's there might be like an explosion, for example, is a perfect thing. It's like, it's not like a fire that's sitting there smoldering. It will explode. It'll emit like a total quantity of particles, and then it's done. So that's an option where you can kind of you can signify a finite limit where it will stop emitting entirely. So there's some of your basic controls up there, and you can get a lot of items into the space, in this through that kind of system. Messing around with lifetime will sort of like reset them. So let's say I'm looking at this. I'm going to work with. We'll take a look at continuous again. Remember, we're emitting from this particle emitter on a constant pulse, and which means that we're emitting 500 times a second. And then you're going to take the 500 times a second. I may have done my math wrong on the last bit. I apologize. Times the emit count. Or I wasn't clear enough. 500 times a second, we are emitting 1. So my math was technically correct on the last case, but had I done this, if 500 times a second we emit a lot more particles, you can see that they are getting, they're kind of getting stamped out a lot quicker. And my computer's getting a little bit jittery. So this emit count can be going back and forth between this emit count, which will give you a certain density in a per unit time, density kind of in with respect to time, and then visually it kind of equates to a certain density. You may work with these two values here, the total that you're emitting in any given time period, and the total that the amount of times in a second that you're emitting. And you also will want to realize, and we can focus on this a little bit later, but it's good to see how little you can make these numbers and still enjoy your overall effect, because any excess in the system is just another kind of tax on your system, kind of penalizing you. So if you kind of want to optimize this by seeing if you're getting the overall effect you're hoping to achieve with lower numbers. So that's something to consider. So that's sort of how you can control the amount of your items, your particles coming out. Let's take a look at some of the other properties. Dimensions and transparency. So transparency and dimensions. So dimensions is the overall size of that particle. and then you've got a scaling in and a scaling out. Scaling in and scaling out. When scale in is 0, that means it's scaling nothing. It's not scaling at all. Like it's not changing its size. It doesn't as the particle starts in. If I change the scale in to 1, it'll literally kind of go from 0 to a full size, and you'll notice that small particles are overlapping less. And in general, these particles are set to be, I believe, additive. They're blend mode. If they're transparent on their edges, wherever they cross each other, they add. So they'll kind of get like a glowing effect and sort of brighten up their when they add up on each other and brighten each other as they overlap. So when we do this fading in and fading out, when we add the fade in and fade out, we may end up with these small particles who don't have enough overlap yet. And so while we came up here and we sort of tinkered with the emit count in the beginning, because it was looking fine, now we sort of changed the effect, and we may need to kind of go back and go back and kind of change our numbers. So you can see now that it goes from basically a 0 to its overall size, and that's the fade. So that's the here on particle emitter. That is on the scaling in. We're 100% scaling in, so we basically go from 0 to 2. If we start, halfway, we'll go from point 1 to point 2, right? Yeah, and you can imagine that there are particles that kind of grow, or they diffuse much more quickly, or have some internally explosive force. So that's another tool to getting an overall look. Fade. Let's see. So scale in, scale out. If you crank up, scale out, these things will they'll kind of wisp down into oftentimes sparks and things like that. Will change. Will sort of fade out like this, like embers. Eventually, kind of fade out like this. So fading in, and I keep saying, scale in and scale out is the right way to describe this. So we're fully scaling out, which means we scale out to 0. Additionally, we have fading in and fading out, which default to 0.1 and 0.3, just for kind of like a decent look. If you were going to fade out entirely, we would go to complete transparency, and then if you're going to fade in from full transparency to fade out, it starts to get overall a little bit lighter, like anyway. So the same thing applies here, and then this is the overall opacity. So if I basically doing halfway here means that we start at halfway to the full amount, which is half of overall opacity. And so there you go. There's a much more lighter wisp overall by bringing the opacity down. So that's transparency and dimensions sort of control that that look of things. Don't worry about instantiation. Continuous is coming off of a pulse, and I am going to now show you what moving is like. And there's 2 ways that are sort of driving the emission. I'm going to call it 3 ways. The continuous pulse can tell this thing when to pulse. Script can tell this when to pulse. And then moving can tell this when to pulse, which means that it's basically how many are we emitting per meter. And so you can jack up this emit rate per meter. And then there's a velocity threshold where I have to reach a particular velocity before I start emitting, so I'm not just emitting all the time. And there's instances where that's kind of that might be interesting for you. Okay, so let's take a look at how we can work with moving. Yes, we can combine moving and continuous, where we're if we're sitting still, we've got our pulse driving us, and but emitting, and we can also then, if we move, we also emit. But what we're going to do is start off with no pulse, and so I'm going to actually deactivate this pulse. You can see all the final particles dissipating, and I got this particle emitter here, and the property of moving, the emit rate, how many I want to emit per meter, and I'll just try 30. And you can see they kind of takes them a second to fade in where they are. Let's do less of this dimensional and opacity fades. Let's bring these down a little bit so there's less of this action and up their transparency. And then they've kind of got this wind on them. Kind of almost blow smoke rings. Let's actually do that. Let's blow a smoke ring. So the way I would do that is I'm going to get rid of the physics, the randomness that's on this force, so it's not waving around anymore. I'm going to remove this attribute, this number signal controller, right here, the number signal controller, track across, remove attribute, and I'm going to take the randomness magnitude and bring it pretty far down. Maybe I'll leave it a little bit, and then I'll just leave. We'll make it go in the negative z direction, so out this way. It has to be much faster. There you go. So, so you can see how moving is working. It's emitting in this when I move it, but not when I don't. The other thing is we're going to be we can attach this to another object, and it'll inherit the physics of that other object. And so I'm going to show you a couple more things. But you can already see here, potentially, let me take off this wind entirely, so there's no wind. You can see, I think, the beginnings of how maybe that blaster that I was using in the beginning worked. These are shooting up in the air. That's my physics. They still are going up. Let's take a look at our physics. Why are they going up? I'm going to put randomness magnitude. There's an initial velocity. I'm going to take that down. And now they shouldn't be going up. They just sort of accept this random velocity. And so you're starting to see a little bit of how maybe that laser shot worked. The blaster in the beginning. So where we are now is with this particle emitter. No, the constant pulse is deactive, or you can also set it to none. And then you set the moving emit rate up to something. Let's see what it looks like with 100. We've got this pretty strong randomness activity. What if we knock this down to just 1, so 1/10 of that randomness? And you see this kind of dusting taking place. Okay, so I'm going to show you just a couple other things, and then we're going to come back and work with this to get it to look like the laser beam that we want. Next thing I'm going to show you is how you connect it to an object, and then how we kind of change the colors and all that. So let's do exactly that. So let's take this box, and we're going to put our particle on this box. We'll call it box entity part. So particle emitter is going to go. You're going to grab the letters here, and you're going to drag it underneath box entity part, and it's now a child of box entity. It doesn't matter actually where it's located in this case. What we're going to do, but just for habit, we're going to zero out the transform of our particle emitter, which is now a child of the box entity, which will put it in its center. And now when we press play, well, first of all, when we press play and we move the box, the particles are going to inherit the physics of the box itself. So if the box is moving, it hands off its momentum to these particles. The other thing that we can do is emit from, let's return this in stop time, is we can emit from the box itself. So this is a really cool effect that you can use to create fog and rain and fire on the edges of things, and it's super cool. So this is, you take the particle emitter, you're looking at its properties on the top level here, and under area, so we'll pull all these up. Under area, you have use parent surface. And so if you hit true and you are the child of a box, you'll note that the box is now emitting from its entirety. And we can use a little bit of, almost like a piece of dry ice or something. And so let's take a look at our particle emitter, and we'll turn the constant pulse back on. And you'll see that it's now emitting from our box all over our box, which is super cool. I think also we've got so many emitting that we are hitting our simultaneous, so we don't get our fade out the way we want it. But yeah, you can changing the lifetime will end up with this little closer glow. This is kind of a fun system to play with a little bit. Just tinker around with this value a little bit and you'll get now that we're emitting from our parent surface, this starts to look pretty cool. With a really short lifetime and a number of them being emitted, you know, these moving objects have just kind of this like shimmer to them, right? And let's see what it looks like to put a little wind into this situation. So we're using, again, use the parent surface on the area, right? Let's see what that does. Cone angle. It's better if they have more. Radius is another option here, which is another way to kind of affect that lifetime. Like lifetime, you can control how far out they get before they. So radius is another interesting way to, like, if you combine radius with, a larger dimension, and you'll notice that when you do the dimensions as they come up, it'll start to tax your computer a little more. But you can kind of get these interesting glow patterns. So that's kind of cool. It's like a force fielding looking thing. Yeah, so what we did there was tinkered with the radius. I'm going to bring it back down to 0. And we've got just kind of this like shimmering, I don't know, it's like a piece of like dry ice evaporating, or something in space getting like magnetic particle, whatever that like cosmic rays or whatever. So it's got a little bit of an aurora around it. What do? We changed the size, so that kind of changes the effect here. And then I think it might be kind of cool to just see what we're doing with wind again. We have a small randomness magnitude, and if we crank that up, I'm seeing them be a little too particly. Like I want them to size out to absolute 0. So that's under dimensions again. So scale out. I'm going to crank that all the way up. Maybe leave it a little bit here. What does scale in get me? Scale in sort of really reduces it. Anyway, you can start to see this, just a lot of different options. Doing this on complex surfaces like 3D models, it basically, the way that this works is that the particle emitter chooses a random location along the mesh of this object and emits in kind of a noise pattern across the mesh, picking picking vertices at each time that it delivers it emits a particle. So again, particle count, we're doing 29 per pulse, and we're doing 83 pulses per second. You can do the math. It's about 2,400 a second. And then they're kind of coming on this random pattern. And it doesn't matter where this particle emitter is on that object. Once the use parent surface is selected, the particles use the parent surface and not where the emitter is. But if I were to click this to false, they will emit from the position of the particle emitter. And so you can see that kind of effect. So we've put them on the parent particle. We've shown you that it inherits the object's the parent object's physics. If you let's do particle emitter. Let's use parent surface again. The particles inherit the parent's physics. I believe, if I'm not mistaken, and we go entities node, and I place a node on this, I make the node a child, and I make the particle emitter a child of that node. I think, yeah, we no longer receive the physics from. If we're placed directly on an object with a rigid body, we receive the physics from that rigid body. So this box entity has a rigid body, and this node does not have a rigid body. So, for example, if I took this box entity and cloned it, let's do it in stop time. I have kind of a clone here. If I get rid of the rigid body, let's actually remove it from this one. If I remove the rigid body here on this one, and place this particle emitter under it, and then I place this one onto its clone that does have a rigid body, I now kind of have the equivalent of a shell for emitting from parent surface. So I can use the parent surface of this one with no rigid body as a child underneath the one with a rigid body, and then I won't emit that, inherit the rigid body physics into my particles. So let's just zero this together, zero out the transform of this child, and now I'm emitting from the surface of this object, and the physics of this object are still active, but they don't overall contribute to the particle emissions. This thing does, leave a trail, which is kind of the echo of its motion, but it doesn't inject momentum into the particles. Cool. So we've worked the parent surfaces. So this is a deep dive into the particles, and how can we build these into a unit timeline and into a fireball. That will be this next chunk of the lesson here. So let's actually figure out how we build a fireball, and then we'll figure out how to make it move, and then we'll figure out how to emit it. So we're going to completely start fresh, and we're going to start with a new particle emitter and get it to be fire. So let's go to our emitter, our particle emitter, and the first thing is we need more particles if we're going to make a ray beam, like what we had there, like kind of a blaster thing. So what we're going to do is go to our constant pulse. First I'm going to pin my particle emitter because we're going to be working on it, like I mentioned. Then we're going to go open our constant pulse that's driving this, and we're going to pin that one. And now we're ready to kind of workshop these two. First, let's crank it up and imagine ourselves emitting at a constant rate. Well, that might not be what we want. We might not care about this frequency. Let's see if that moving, if the moving value is the one that we want. So let's go to our particle emitter, and let's use the moving value, and we'll move this, as we move this particle emitter, that's what's going to make it emit. Let's pick up a certain amount of emission, so 20 per meter. Let's do like 100 particles per meter. In playtime. That's good. That's fine. We can start here. That's a place to start. Clearly, I don't, right off the bat, I don't like their I don't like the physics of them. I don't want to emit them with any initial velocity, and I want the wind to be really minimized. I kind of like what it looked like at around 1. So let's imagine I move it, and I get this kind of dusting out. That's fine. I actually want this randomness magnitude to be even less. I'm going to make it like 0.2. There, it kind of looks like a jet stream, a little chemtrail guy. Boom. I want it to like fade in more. It's like so full, like it's full radius when I start. So I want the dimension to scale in. So I'm going to leave physics alone for a second, and I'm going to work on the dimensions. So I'm going to scale it in quite a bit, meaning that it'll be small when it starts out and then it gets bigger. That's pretty good. I'm going to make its lifetime a little bit shorter so that it's not sitting there for quite as long, and see what that does. Lifetime is kind of eradicating these before I think the simultaneous is. Just fine. So shoot it, holding down shift to move it. I kind of like that. It's like, looks pretty lasery for a moment, and then it looks kind of gas-like. Okay, I kind of like this. And I don't think I have much to comment on the transparency. The physics is fine. Maybe there's more that I want to omit in a moment, but I don't need to worry about the constant pulse. I'm not putting it on something, so I'm not really going to worry about area for the moment. This is a fine amount for simultaneous, and I've reduced my lifetime just a little bit. So now I need to work on the color a little bit, and so this is another part of the particle emitter system. So you can work the pulse if you're working on that, the properties under the particle emitter all through here, which we've been working on, and then expand out the material. This is what's in the particle. It'll actually take a texture under its. It has a texture map, not the diffuse map, but I think is it detail, diffuse map, illumination, self-illumination, geometry, diffuse. Right here under translucency, it's the opacity map, which you can find the particle. It's actually looks like this, and reads the red channel for opacity, or reads the alpha channel for opacity, and then it takes a diffuse color and throws. Basically, the way that it works is this: the particle has an opacity map that basically makes it opaque only in the center, and then it's basically feathered on its edges, so that it is zero opacity on its edges, full translucency. So here we go, and so that's under the opacity map, and then it is a a particle with a full color on its diffuse side. So you can tinker around with these properties. This is a little bit of a deeper lesson for kind of all down into the materials, and a lot of people who are more familiar with this will instantly kind of begin to kind of want to tinker around. So you can put all kinds of materials in here. You can literally make the map, the texture map for diffuse be an incoming video stream. It can be kind of all kinds of stuff. So highly invite you to tinker around with what you can do with the materials here. You can put in things that look more like stars. You can put in animated textures, so on and so forth. What we're going to do is just tinker with this color. And what we're going to do is create here what's called a color components attribute, which breaks down the hue. And we're going to find a way to get ourselves a hold of this area of the hue. So we're sort of in the fire area. And end up picking a range in this area for our particles as they come out. And so once we have the color gets broken down into this hue, saturation, brightness, alpha by creating left clicking on this little triangle and adding the color components attribute. And underneath it is this hue slider. And then you can take the hue slider or this hue property and create a number signal sampling attribute, which will sample this value. Excuse me. Just test if I've done this right. I think that under hue, let's do normal distribution sampling attribute. Excuse me. I think I said normal. I read number signal. I want normal distribution sampling attribute. And what you do is you're going to pick a standard deviation around where you're going to kind of pick around this range. And this is the standard deviation, which is, the amount that you're going to pick kind of around this value. And then you can choose the range either being above and below or just above or below. And so we're going to go from kind of either side of this with these kind of standard deviations. So the probability drops off like a normal distribution. So the probability that we get this becomes highly less likely and this much more likely. So we'll take a small standard deviation around the orange color, and what that should do is give us a look that I think we should be working there, where we have a combination of reds and yellows. Let's just double check ourselves. If we were up here and crank this up. Sorry, I'm just trying to figure out. I'm not getting the effect, but I'm wondering if that's why. Yeah. The diffuse color source needs to be material plus object color. It had been just set to material. The object color is this color that we were testing, and so you need to change it to material plus object color, and so now you're going to get this to work properly. So now I can create a small standard deviation, put myself kind of in the middle of a range that I want to sample from, and now as I sample, I'm going to be sampling values in various ranges. We are getting a little bit more oranges and reds. So yeah, so you can tinker around with the color and effect in this fashion. Now that I'm seeing it in color, and I'm kind of dialing in these, I'm dialing in the kind of that deviation around this color. Whoa, just tinkering with the brightness. Overshoots quite a bit. Tinker with the brightness. You can get yourself into like kind of a neon territory. You know, I think 1 is full brightness, and then everything after that starts to like be like glow. Like HDR glow. That looks fairly good. It kind of spreads out in a way that I'm not super in love with. Like potentially it's the lifetime could be shorter, or my overall on the particle emitter, my overall dimension is just like a little bit bigger than I want, so I might want this down to like 0.1. Mistake there. Dimension 0.1. Okay, there's a little element of green in there. I think my deviation kind of hits it, but it's not bad. It's not bad. Not bad. Maybe my wind could be tamed a bit. I don't know. This randomness magnitude could come down just even a little bit more. I don't know how I feel about that. I feel like that was at least working. I think I want the dimension to scale out a bit more. It seems to kind of that's a little better. What was my randomness magnitude? Bring it back up. Anyway, yeah, you can kind of sit here and dial it in. Okay. Good enough. We're going to use anything like this. You can obviously make it exactly how you want. You can throw more particles per your rate. Densify how thick that particle stream is as it moves. Last thing I'll do is probably change the overall lifetime. I think I want it to be a little bit smaller, and then. Yeah, I kind of like that, where it's a bit more fades out a little quicker. Okay, so that is a basic initial lesson, kind of a thorough overview of the particle emitter. So now we need to get this thing to move. So let's just animate this thing in a unit and timeline. So what we're going to do is create a new unit plus timeline. The new unit plus timeline opens up as such, and there is a new unit here in open space 2, and we see this arrow meaning we're down in unit space. We'll double left click to come back here, and we're gonna cut using Control X, and then double click into the unit, and then paste our particle emitter. So we've pasted our particle emitter into our unit, and this unit, it has its own timeline. So when we double click into the unit, we have this timeline inside the unit called timeline, and I'm going to change its name to unit plus timeline. And now I can see that unit and timeline is based here. And so what I want to do is take my particle emitter and send it on a trajectory out in the forward z direction, out away from the origin, and get it out. I don't know how far ever I want to shoot, like 100 meters or something. So the first thing I'm going to do is I'm going to put my particle emitter. I'm going to put its transform at exactly 0, 0, and get rid of any rotation. I want it to be in the exact center of my unit, so that if I emit my unit from my fingertip or like a gun or something, I want it to come out at that exact point. So I've zeroed it in, and now it's right at where its parent is. It's the center of the unit. And now what we need to do is create a key track on the unit timeline. So if I go to the particle emitter and go to its properties, and on the top level here, I click this little button. On transform. On transform, I'm going to hit this little triangle, hit new key track. So the transform is going to get a new key track, and it comes down here. And what I want to do is basically double left click, and then drag that little keyframe to time 0. And that's going to be, as I right click, you can see that's position 0, 0, 0. And I'm going to say it's going to take, it's a 2-second shot, or let's call it 1.5 seconds. I'm going to right click. I'm going to say at 1.5 seconds, I want this thing to be out at 100 in the Z direction. And then I'm going to right click, and I'm going to hit just smooth. I guess you could try exponential ease in. You could try a bunch of these. Maybe we'll tinker with this. But what's going to happen then is the key track is going to set the position of our particle emitter. When it feels itself getting moved, when it sees this getting updated, it's going to use its moving, like we were doing, to begin emitting exactly how we had done it. So let's take a look at what that looks like. So that kind of looks like something that is self-propelled. It maybe doesn't look quite like, the speed of it to me doesn't seem quite like a projectile. So I'm going to hit stop here, and I'm going to grab our final destination keyframe and drag that back down to like 1, or just less than 1. So that looks a bit more like I'm firing something and shooting it. It almost could be a little faster. And you can try different keyframes, like circular ease in, or sorry, those are called interpolations or ramps. And you can see these different. That one's strangely fast, circular ease in. What's exponential ease in look like? Also very fast. So let's go back to smooth so that we can progress here. And we'll make it even a little bit faster. Okay, so now we have this unit that, when the unit runs, it's sitting in our space, and when it runs its timeline, its timeline tells the particle emitter to extend out in the 0 direction, jump out in almost 3/4 of a second, go out to z equals 100, go from 0 to 100. So now what we need to do is figure out a way to emit these units. And we're gonna do one other thing. Let's throw one other little nice little thing in here. Let's take a point light and we'll toss it into space, and we'll put it onto the particle emitter. And so wherever the particle emitter, so will go the point light. Let's zero out its transform and put it right where the particle emitter is. And let's make its light a little bit more yellow, bright, and we'll crank up this a little bit. So now we've got a thing that's emitting light and a thing that's these kind of glowing particles. And we press play, we extend it, and then we end up with this little light out in the distance. So let's emit this unit that has this little thing that's going to move along its dimension. Let's emit a few of those. So we're going to use what we were talking about in the beginning with this particle emitter. Sorry, the node emitter. And this node emitter is going to emit these particles. And so we need to just do some things to our node emitter. First of all, we want to emit a full copy. We don't want to emit a shared copy. We want to emit something with completely new, sort of unique information. And you'll see what happens if you do shared copy. What you emit after the fact, you'll be emitting the original in its full state. And what that'll mean is the timeline will already be out past where the particle emitter is at its final destination. So we don't want to do that. We're going to make this a copy. We're going to clone as full copy. And then we need to pick what our sample is. So we're going to pick the unit, and that's where the magic happens. So we now we're going to emit these things as full copies, which means that every time we emit these things, they start at time 0, and we get a new light and a new particle emitter shooting out 100 units in the forward direction. So there we go. So now we can see this one. Once a second, we're shooting these things out. I can rotate it, and perfect. We basically have the beginnings of a ray gun. We just need to tell this thing to when we want it to be shooting these things. And so let's do that. First of all, this node emitter. We're also going to do a couple of things. We're going to take the physics and put no velocity on it. It doesn't really matter in this case, but it kind of does. But let's just zero out the velocity. And basically what we're going to do to make it stop emitting them 1 per second, we're going to basically set its continuous to none. We're going to call this node emitter in script. And we're going to do it on the VR rig. Let's set up a sample of what we're going to do by clicking this box. So we're going to make this box a button, and then we're going to do it on the VR rig. So we're going to do it kind of twice over. So this button, we're going to make it this box. We're going to make it into a button by hitting up here on this little triangle. We're going to go add interactable, which makes it now has all these interactions on it. We can say on press. On press, we're going to go get the node emitter, and that node emitter won't be emitting. Here, let's show you. Yeah, it's not emitting. The first one will emit, and that's just the unit expending itself. Yeah, but now the node emitter isn't emitting. The node emitter is waiting to get called here. So, for example, the code is node emitter : lowercase emit, uppercase N OED ODE, emit node, open close parentheses, and that's the function to emit a node from this, which means that if I click back into space and click on this box, I'm now emitting that node. Very cool. So it's basically this line of code, and we just need to find the node emitter. So we'll go ahead and delete that box, and we're going to put a VR rig in the space. Let's go ahead and let's use the preset, or let's use a blank one. And but set it up to basically, let's set up the VR rig to have the, we're going to make it fly with our left index trigger. So we can do, under VR, we can say press to fly, undock this panel, and put it on, click the index trigger. That uses our index, that'll make our index trigger to fly ability. And then we will use press to interact. Sorry, not press to interact. So we wanted to fly on one hand. That's good. So now we're flying. And now what we want to do is build the interaction on the right hand. On the right hand, we're going to end up with we're going to create an event that is the press event of the index trigger. Let's see here. Let's see if we can make the VR rig, make our node emitter emit. So if we press our right index trigger, the on press of our right index trigger, let's run that same code in this case. So we're going to be doing this a few different times, and you'll see it happen a few different ways. So I'm going to go get the node emitter by its unique ID, like its code, social security number. Node emitter colon emit node. So when we press our right hand index trigger on press, the node emitter emit node is going to, the node emitter is going to emit a node. And so we're in VR, we hit the VR button, place the headset in front of us, see if there's, I can see my, so yeah, so when I press the right index trigger right here, I'm emitting that node that's in space. So now you can see that all I need to do is connect this to my hand. I'm gonna do the code slightly differently so that you can see it done in two different ways. So let's connect the node emitter to our hand. But I just wanted to review what I did here. And I'm going to do it from the top. Again, I just sort of did it and wanted to make sure that I was doing it right. So under VR, let's do this one more time. We're going to put in a blank rig. When we place the blank rig in, we've got our left hand or right hand and our HMD, and under each hand is its trigger. What we want to do is put the automated fly locomotion by clicking under VR AR. We're going to press to fly, and we're going to put it on our index trigger, which allows us to now fly by using that index trigger. And you'll see that there's this little fly script node, and it has this little pink thing that shows script and edit code, and there's the thing that it just stuck in there. We need to make this, we need to put a little, just like we put that interactable attribute on the box in the space, we need to put that on our little index trigger down here. So we're gonna come up here and we're gonna say add interactable when we're selected on our right hand index trigger. On interactable, we're gonna click on press, right? And then in here is where we wrote that code. And the way to do that was we grabbed the node emitter, brought it in, and then we spelled it just the same, and colon to run the function, emit, lowercase, uppercase, NODE, open close parenthesis. And then when we go into VR, when we press our index trigger, we're shooting the ray. Perfect. So literally all we need to do now is take the node emitter and drag it onto our right hand. And then we need to place it. We need to zero it out so that it places directly on our hand. And then I think what we want to do is get rid of its rotation. That was some arbitrary rotation. And then I think we should be set. And if we're not, we might be just off 90 degrees. And let's just double check if when we point our hand forward, we shoot in the forward direction. Phenomenal. That's a great feeling. It's like shooting a fire ray out of my hand. So, perfect. We have arrived. We spent a long time getting our particle dialed in. We had to learn a lot about particle, but the last two steps were super simple. We really just created a VR rig and then put an interactable attribute on our index trigger, and then wired it up to the node emitter and put the node emitter on the right hand. You could also have done that in reverse order, put the node emitter on the hand and then wired it up there, and that would be just fine too. Another way that you could do this script, I'm gonna show you, would be that I could find this relative, not by using this. I'm gonna edit this code. Right now, we found the node emitter by its this find by object unique ID. And this is like finding it by its social security number. I could also find it another way. I'm just going to comment this out for a second, which means this code won't run. And then what I would do is say, well, if I'm the index trigger, and I want to get my sibling that's sitting at the same level as me, my node emitter, I could say get my parent, and parent go get node emitter. And so I can basically write self, which is me, colon, get parent, uppercase P, parent, uppercase node, open close parenthesis, colon, find, lowercase f, find node, uppercase N by uppercase B, by name, and then I open close parentheses, and then I am going to spell out node emitter inside of quotes, inside the parentheses, uppercase NODE, no space, uppercase E, emitter, and now that returns our node emitter, and then I can just say colon, emit node, which means that this right here signifies the node emitter, and then we run emit node. So basically, by saying node emitter equals find object by unique ID, node emitter emit node is literally the same as, well, hey, I'm the on press event for the index trigger, otherwise known as mesh entity. I can go get my parent, find parent node. I can, once I found my parent, I can tell my parent to search for its children using find node by name to get node emitter. And this chunk right here is literally the same as this, which is two different ways of finding it, by unique ID or getting the parent and then finding the child. So it's always key to kind of look at that and know that you can do know how to kind of find things relatively, and it's really good practice. So you can also make things that clone out. We're not going to be cloning this VR rig a bunch of times, but anyway, so that should get us to the same functionality. Let's just double check, and we're blasting. And it's kind of cool. We get a first little blast of light that comes out of that point light that jumps in, and it kind of gives us a lens flare because it's close, so we get a little bit of a light explosion. If we crank up the value of that light inside of our particle emitter, inside of our unit, if we take this point light and jack up its area radius, we're going to get much more of a burst when we first emit. Oops, here, hold on. Let me go do it in VR. So I think we're seeing a bit. It's not that. Not super. There, it's kind of. Anyway, so let's just enjoy what we've created by building out kind of that apparatus, that weird. I built like a whole bunch of stuff, a bunch of like boxes. I sort of took like some chunks of stuff like this, and then I literally just sort of cloned up using kind of shift and drag, cloned up some boxes. I'll save those positions, committing transforms. So I just zoomed kind of way out to get a bigger. I can hold down Control and the scroll wheel and scroll forward and be able to move the camera faster if I want to kind of cover more distance. And then I just sort of cloned these and angled them into kind of interesting ways and got them into a geometry that gives me interesting kind of parallax and fun space to work in. There we go. So now I have this complex. So maybe the next one is we could build a way for these to light the boxes on fire. And that could be like particle emitter round 2. And you can see as the point light goes through these, it does light them up. You can see them actually lighting up temporarily, which is that's one of the reasons I put the point light in there, not just for the flash on our end. You could also, you notice that the point lights kind of end up in space, which is kind of hilarious. Like, it's like I give birth to a star or something. But you could, if you wanted, turn those lights off using a timeline. Using that same timeline. So it might be hard for you to see there. If I go to edit, preference, let's see. So one of the things that we could do, for example, in this unit, we could start adding a bunch of different things into here. Like the point light, we could make its area radius super big. Actually, I can change the color of this point light over time if I want. So for example, I could take this color and I could make a new key track, and I could make it like blue at the beginning, and then go really quickly to something else. Go to white, let's say, or it could be like blue, kind of a bright blue that then goes to like purple. It'll probably go through. That's going to end up going through a spectrum of color, but I think. Oops, let me do that in VR. It's kind of cool. We'll fly away a little bit. I'm going to kick off this blue. The light flashes. Kind of cool. You get that little bit of a blue effect. I'm going to get you guys the full screen preferences on my outputs of my this HMD. Add a new screen display so that you see monoscopically here. I'm going to make me fly faster. For example, under the VR rig, under fly, I can edit the code. And instead of multiplying this by this 2 value, I can make it 22 and close it. And now I should be flying much faster. There we go. There we go. Now I can kind of see the color change a little bit. Well. Oh, that would be another interesting thing. Since I've dropped them into a position, I could then go to I could make this color kind of change over a much longer time frame. So it would sit there. Once it like lands in its position, it would still sit and kind of smolder through a few colors. Look at that. I will fly. I keep hitting just play. I think I need to hit. Fly away. Kind of cool. Now I'm just like injecting. It's kind of cool to shoot out a few and then like come to a new position on them. It really does look like I'm attacking this thing. We could basically get rid of that light after a little while, we could kind of turn it off, which might be a cool way to have it kind of basically dim out and then die. So for example, I could come to the unit and take the point light and any of these values basically. So I could take area radius and go new key track, and then active, I could go new key track. And so basically I could have this thing be at full value here. This is the area radius key track, and then I could dim to some amount over in a smooth fashion. I could dim out to 0, and that'll go to dim. And then once we're dimmed out, I'll go deactivate. So I basically I'll be active true right here, and then here I will be false. So that I'll go from true to false after I've dimmed out and my color has gone through its thing, and I'll be sitting in a final position here. Could be interesting to turn our particle emitter on at, so it's not just moving, but there's a constant pulse affecting it once it gets to its destination as well. So that could be interesting. So right now, do we have one? We do have a constant pulse. So this constant pulse is false, so we could put a new key track there, and I'll call that name my tracks in good habits. This is light, point light. This is point light, area radius. This is point light, color key track, transform key track. This is particle emitter, transform key track. So the constant pulse we could turn on once we get to its final destination. So it could be active false, active true. So once it gets to its final destination. Kind of cool, you end up with the lights have now kind of have a little particle glowing with it. So you could jack up some of those values, which make these things sit like little hovering fireballs. What would we do there? Increase the lifetime and the size. So we could do that. Come back into our unit, double click, some particle emitter. We could do lifetime, new key track, and the randomness magnitude. Do a new key track, and the size could jack up to new key track. So particle, just make sure I get my names. So once they get to their final destination, kind of in this space, I'm using the scroll wheel to zoom in. Sort of make these all kind of go up in one value, the same. I'll just ramp up either smooth or linear, and then the lifetime is going to go up. So I'm right clicking on that little keyframe and kind of changing a value. The randomness magnitude, kind of that windiness, We'll bring up a little bit, and then size. We'll bring up a little more. Now we should have these kind of glowing balls. Not sure why that didn't. Okay, very cool. I'm just going to sit and tinker with one more thing. Well, there you go. We've had a lot of fun. We have created made a lot of progress on learning about the particles, and we've placed an emitter that emits a unit in a timeline, and in that timeline is a particle emitter with a light, and it's using its moving property, and we get this kind of ray beam blaster thing, which is fun to shoot at stuff. I think next time what we'll do is create a system to basically allow us to identify if we've correctly hit a target, and then we'll set that target on fire. Very cool.